So you hear it all the time, right? AI is transforming our world. It's doing these incredible things in medicine, science, you name it. It feels like every single day there's a new headline about an AI doing something we thought only humans could do.
And here's a perfect example of that hype. I mean, think about it. An AI passing the U.S. medical licensing exam, that's one of the toughest tests in the world. On the surface, that sounds incredible. It makes it seem like these things are practically infallible.
Okay, but this is where we need to pump the brakes. Because getting a good score on a test is one thing, but putting that same AI in a real hospital or on a battlefield, that's a whole different ballgame, and it brings up a really critical question.
And this gets right to the heart of the matter. We have two very different ideas here, performance and reliability. Performance, that's like acing a test in a perfect, quiet classroom. But reliability, well, that's about whether it works correctly out in the messy, chaotic, unpredictable real world. That gap between the two is exactly what we're going to dig into.
This is what we're calling the AI reliability gap. It's that kind of scary space between what an AI can do in a lab and what we can actually count on it to do when the stakes are sky high.
Let's break this down a bit. The key phrase here isn't high score. It's without failure. This means we have to be able to predict the odds of it messing up in a specific real-world situation. I mean, think about it. A 99% success rate sounds amazing until you realize that 1% failure could be, catastrophic.
So how exactly do these systems fail? Well, it turns out there are some very specific patterns. This research actually lays out 8 different ways they can go wrong, and we're not talking about little random bugs here. These are fundamental, baked-in problems.
All right, first up is a big one you've probably heard of, hallucinations. This is basically when the AI just makes stuff up. And the really dangerous part, this isn't some rare glitch. It's just part of how these things work. And when they state something that's totally false, they do it with absolute, unwavering confidence.
And you can see how this gets serious fast. We're not talking about it getting a trivia question wrong. A hallucination in a hospital could mean a doctor gets a completely fabricated lethal drug dosage. In a courtroom, it could cite a legal case that doesn't even exist. The consequences are very real, and you can't just hit undo.
Now let's look at the next one, because it really builds on this idea. It's called overconfidence failure. It's a lot like a hallucination, but it has this extra dangerous twist, especially when you have a human trying to supervise it.
So here's the problem. The AI isn't just wrong, it's confidently wrong. It presents its mistake with so much authority that it can actually make a human expert doubt themselves. This just completely blows up the whole idea of having a human in the loop as a safety net. I mean, if the AI can trick the expert, what good is the expert?
And believe it or not, those are just 2 of the 8 major failure types they found. Just look at this list. You've got stuff like prompt fragility, where just changing one word in your question sends the AI off in a totally different direction, or temporal drift, where the AI just quietly gets worse over time after an update, and of course, adversarial manipulation, where bad actors can actually hijack the system. Every single one of these is a huge problem.
So this all begs the question, if AIs have all these problems, how in the world are they acing these super hard exams? Well, it turns out maybe the problem isn't the AI. Maybe it's the test itself.
And this chart just lays it all out. When you give these medical AIs a multiple choice test, they do great, really high score. But if you take away the options and ask them the exact same question in an open-ended format, their performance tanks. We're talking a drop of more than 39 percentage points. It suggests they're really good at recognizing an answer, but not so good at genuine reasoning. Here's the best way to think about it. It's the difference between acing a pop quiz and actually performing surgery. One tests memorization, the other requires deep, adaptable knowledge under immense pressure. Right now, our AI tests are basically giving pop quizzes. But what we need to know is if the AI can handle the surgery.
Okay, so this brings us to the core issue. You can't fix a problem that you can't properly measure. The research here argues that we need a completely new way to evaluate these systems, one that's designed for reliability, not just performance.
And they propose a 3-part solution. First, build brand new, tougher benchmarks that are specifically designed to provoke failures like hallucination. Second, create a new grading system, an operational reliability score that actually penalizes models for being confidently wrong. And third, deploy targeted stress tests that attack specific weaknesses, just like we would with any other critical piece of engineering, like a bridge or an airplane wing.
All right, let's bring this all together. After diving into this gap between performance and reliability, what are the most important things to remember from all this?
First, and this is the big one, performance is not reliability.
An AI can ace a test and still fail spectacularly in the real world. Second, our current tests are simply not good enough to certify AI for life or death situations. Third, these failures we've talked about aren't just bugs to be patched. They're systemic risks that make going fully autonomous really dangerous. And finally, that means meaningful, skeptical human oversight isn't just a good idea, it is absolutely essential.
Look, AI's capabilities are growing at an incredible rate. There's no question about that. But this research forces us to ask a different and maybe more important question. As AI becomes more powerful, what are we doing to ensure it also becomes more reliable? The answer to that question is going to define our future with this technology.